Okay, when we're looking at numerical data rather than categorical data, we have a different way we can display these. The first display I want to talk about, just like we talked about above, we talked about the frequency table. So when you're displaying numerical data, you can put it into a grouped frequency table. Which is exactly the same as the frequency table above, but you might have 30 to 34, 35 to 39, 40 to 44, and keeps on going like that. And you would have the frequency. So this is the groups, and the frequency, you might have 2 in here, 6 in here, and 9 in the final one. Second way we can display numerical data is using a histogram. And that's just like a bar chart, but this time there are no gaps. So all the bars are squished up next to each other. And the last one I've got here is a dot plot, which is where we have a scale going along the bottom. And we put a dot for each data point. So I have 2 here, 3, 1, and 2. Dot pot. I need an L in there. Dot plot. Makes a lot more sense. These displays are best for if you have a skewed distribution. If you have a symmetric distribution, you can use the second one I'm about to show you. But for skewed, these 3 work, along with the next 2 that I'm going to go through as well. Calculations for each of these. For the grouped frequency table, we can calculate, just like in the categorical section, we can calculate the mode. For the histogram, we can calculate the mode. We could also use our log scale transformation to make it easier to read a histogram with very large or very small numbers. And with the dot plot, we can easily read the mode off there as well. In histogram, you can read the mode as well. Now, when we're writing our report for numerical data, we're going to use SOX, which stands for Shape, Outliers, Center, and Spread. To write a full report, you need to make sure you mention each of these categories. When we're talking about shape, it's hard to find the shape with the grouped frequency table, so you'd need to look at using histogram or a dot plot. We can talk about the distribution being peaked, so it goes up like a mountain, up to the top and then down again. It could be flat, all the values are around the same. It doesn't have to be perfectly flat, but just around the same. It could be symmetric, this one is very symmetric. Or it could be skewed to one side. The shape can be bimodal, so you could have 2 modes like this one here has. And this one here would be skewed because all the data is pushed towards the positive side, so this one is negatively skewed. When you are describing any outliers you can see, you need to make sure you list them as possible outliers, because we haven't calculated yet the upper and lower fence. So things that just look like they're a bit out of place, just put them down as a possible outlier. The center of your distribution, you can easily work out the median, which is the middle number, and that would be the best way to describe the center of these types of displays. And the spread, you can use the range to describe it. So the range is how far from the lowest value to the highest value. So the range of this one is 10 minus 2, 8 altogether, 8 data points in between. Two more displays we can use for numerical data that is best for skewed data. First one is the stem or the stem and leaf plot, where you have the stem here. This might stand for 10, and you just put in 12, 14, 16, 20, 1, 23, 28, 30, 4, and 9. Final one I want to leave enough room for is the box plot, which is the one that looks like a box or box whisker plot. Looks something like this. It should have a median in there as well. Calculations for the stem plot, much the same. You can find the mode by counting up. You can find the median fairly easily. Calculations for the box plot, you've got the 5-number summary, which is the minimum, Q1, the median, Q3, and the maximum. Q1 and Q3 are the quartiles, first quartile, third quartile. The second quartile is the median. And you can also calculate the outliers accurately by using the median plus or minus 1.5 times the interquartile range. And the interquartile range is the difference between Q3 and Q1. Using our socks to describe these last two purple displays, we can easily look at skew as well as all of these types of shape. We can now calculate the outliers using our formula, m plus or minus 1.5 times the interquartile range. So they're no longer possible outliers, these are definite outliers if they're outside that fence. The center of our spread is still best described by the median, and we can show the spread by using the interquartile range as well as the overall range. These types of displays are best if you have skewed data. So if you graph something and you notice it's skewed, it's best to use one of these ones. If you have symmetrical data, it's best to use the next one I'm going to show you. If we have numerical data that is symmetric, then we're best to use the normal distribution. This only works with symmetrical data, does not work with skewed data. Normal distribution is useful for data that looks like this, with a tail going down at each end and a nice, sometimes it's called a bell-shaped curve. Calculations we use with the normal distribution is the 68, 95, 99.7% rule to show us where 99 or 68% of the data is in between 2 points. We can find the mean of the data easily, and we can find the standard deviation. We can also standardize normal distribution scores, and they're sometimes called Z-scores, and this will take any distribution and make it into an easy to understand normal distribution, as long as it's symmetric, so we can more easily find different points and see how the data is spread out. When we're describing our normal distribution, the shape is going to be normal or bell-shaped. It's definitely going to be symmetric, otherwise you wouldn't be using the normal distribution. And it doesn't have to be perfectly in a bell shape. If it's close, then you can use the normal distribution to approximate the values. Outliers you could list as possible. The center of the spread is best described as the mean for the normal distribution, which is the average of all the data points, and the spread is described by the standard deviation. Deviation. Try again. Standard deviation. Hopefully this video has given you a bit of a summary of the types of data displays you can use for univariate data when you only have one variable. Thanks for watching.